We will explain the difference between VLAN and IP subnetting.
We will explain the practical use in companies and why do we resort to using VLAN and subnetting in companies. What is their importance? If I have a company building consisting of 5 floors and in each floor there are 100 employees, if we work as you have at home, we will use one elephant. This means that the network will be 192.168.1.0, the gateway will be 192.168.1.1, and the broadcast IP will be 192.168.1.255. Then I will be able to distribute IPs from 192.168. 1.2 to 192.168.1.254 means that I will distribute 253 IPs. Of course, I have a number of employees of 500, which means more than the number of IPs that I distribute. I don't have only employees. There are also printers and servers, and there is a lot of other things.
One VLAN is not enough.
So we will make more than one VLAN. The first reason is because we want to distribute more IPs. The second reason is that I am preventing 2 VLANs from talking to others. What does that mean? I mean, for example, I want to create VLAN for servers and VLAN for IT employees, and I allow the IT VLAN only to access the server's VLAN and the other VLANs of the employees cannot access server's VLAN. So this is the second reason. The third reason is that I let each VLAN use its own printers and cannot use any other printers. Another way to reduce broadcasting? When 2 computers in the same VLAN talk to each other, for example, VLAN 2, in this case the switch will be sent to all the devices in VLAN 2 to search for it, and it will not be sent to VLAN 3 or VLAN 4. If there is a device in VLAN 2 that wants to talk to a device from VLAN 3, then the switch of VLAN 2 will not sent to the devices inside his VLAN. It will be sent directly to the switch of VLAN 3 and will not be sent to VLAN 4. For example, I will have VLAN 2, VLAN 3, and VLAN 4. VLAN 2 will be 192.168.2.0, which is the IP address of network, and subnet mask 255.255.255.0, VLAN 3. 192.168.3.0 and VLAN 4 will be 192.168.4.0. I will increase the speed in network and reduce the traffic. Okay, we said that we will use the IP that is 192.168, such and such. This is a class C IP. Okay, why did we use the class C IP, and what is the class C in the first place? Let's see. As you can see in the picture in front of us, the IP is divided into 3 classes, Class A, Class B, Class C. Each class has a specific range. I mean, as soon as I see the IP at the beginning of 192, I know that they are along Class C, and so on in the rest of these classes. They differ from each other in the number of networks and the number of devices. I mean, in a class, I have a large number of networks, but give me little IPs for every network and vice versa. I have a Class A, with a small number of networks, and a lot of IPs, so I use it if I need a few networks, but I have a large number of employees, Class C. I have a large number of networks, but the number of IPs is small. I mean, I use it if I have a small number of employees and a large number of networks. Class B, in the middle between Class A and Class C. Thus, we understood the importance of the VLAN. Okay. Why is subnetting used now? We are working in Class C. This means the number of networks for Class C. It is 2,097,152 networks per IP. I mean, I am in the first one that I used, for example, which is 192.168.2.0. The IP of this network is Class C, meaning it contains a very large number of networks. I mean, when any device from this network comes to talk to another device, it is sent to every the IP address of Class C is used to find it, and this of course provides a lot of traffic and makes up the network. That is why we use IP subnetting. What is IP subnetting? We specify a certain number of networks, and cancel the rest. We determine the number of networks according to the number of computers. This means that I have 3 more important VLANs, or we say that they have 3 networks, We will divide each network into a number of networks as you can see before us. Basically, I use class A or B, or C, depending on the number of computers I have in the network and the number of networks that I need. Here we used class C, so we will divide it into the first network into a number of networks, and each network has a number of computers or a specific number of IP addresses, as you can see before us. Thus, we divided it into 4 networks. And each network is 62 host, means you want 62 IPs like this. We made an IP subnetting for the first network or for VLAN2. We will also do this for VLAN3 and VLAN4. In this case, the IP that the device will be like this, for example, meaning 192.168.1.10, and the subnet mask 255.255.255.192. This is the IP. The network's network will be 192.168.1.0/26, and the subnet mask is 255.255.255.192. Before we do subnetting, any device in the network that take an IP like this, 192.168.1.10, and subnet mask is 255.255.255.0. Which means all Class C networks will be sent to it, but after that we did subnetting, the subnetting mask will be 255.255.255.192. This means that we use some IPs, not all. That's why we call it IP subnetting. So the device is in this state when it sends to another device. It sends only to these 4 networks. I will leave you a link below the video that explains the IP subnetting and how we divide the network according to the number of hosts, and how we choose suitable class.